You there?
Yes, I'm here.
Can you share your screen just so we can be sure that there's no problem with that?
Yeah. So now
Okay,
I'm sure.
it's working perfectly. Okay, thank you. Actually, you're the first one to be presenting, so please leave it
Yeah.
there.
Okay.
All right. Apologies to everyone for being some minutes late. We just came out of a very interesting meeting about ourselves, our organization. And now we have to come back to the academic mode, not just the organizational mode. And thank you very much for the opportunity to be presenting this session about scientific communities and other tools. We are going to be starting with a presentation by Francisco Cardozo, who is from the University of Miami, and his presentation is titled "R Packages for Network Analysis." You'll have 15 minutes to present. We'll let you know on the chat that you have 5 minutes left and you have 1 minute left. So that's pretty much it. Francisco, the floor is yours.
Okay. Thank you. First of all, thank you very much for maintaining this hybrid format. I really appreciate the effort from the organization. And today I want to present this small project. It's called R Packages for Neural Analysis. It's something that it start after the summer conference, which I had the opportunity to go and met so many people that were using so many different art packages. So I was like thinking like maybe it would be a nice idea just like to try to see the overview or the overall overview of all of the packages that are available in R for network analysis. It's important to say that packages in R, I hope everybody knows what is a package in R. It's basically a collection of functions that are like put together into one folder and then you can like share and use. So I'm Francisco. I am a PhD candidate in prevention science and community health at the University of Miami. I'm also a data scientist, and my research is an evaluation of prevention in preventive programs. And lately, I have been using AI to integrate AI into prevention science, into preventive intervention, actually in the implementation component of the intervention. And I use network analysis when I was doing my master's in psychology, and I mean, used it ever since. And I also have been using R a lot. I use R for many of my projects, and then so this is like two words or two software. I mean, the methodology of networks and R. It's something that I really enjoy. So I was like thinking, like, okay, this is like a good opportunity to show something that include both. So the goal is to present this overview of the R packages for neural analysis, and I use different approaches. I decided to show you this one, and basically like a rapid overview of this is I extract all of the packages descriptions from CRAN, and then I use this method that is called embeddings to identify which packages are network packages or packages like they're created to use network analysis. And I think that's the most difficult part of the analysis, so we can maybe discuss at the end about this. And then with the information of the network packages, of the packages for network analysis, I create two different networks, and one network for dependencies among packages and another network for collaborations based on authorship of the package. And then I use a Shiny App application that I think is the most important part of this presentation. I just wanted to show you the Shiny App and visualize the networks. So the motivation for this, R is very popular. R is free. You know, there's a lot of things that are really good for R. There's like transparency in some of the code, so you can check, you can see, and you can use many of the packages for free. And there is like this big system that is called CRAN, in which you can find thousands of packages. Actually, there is like 27,000 of packages for many different purposes, not only statistics, but now we have things for web design and things like that. And at the same time, network science has been like growing, and then so I met people using packages that I never heard before, and then I start like changing packages. So there is like probably new package, and I'm thinking like, should I change or should I try this new package? So there's like this like big increase on the in the use of R in the network packages. And finally, what I was thinking is, okay, so if we have like these networks of collaborations or this network of scientific like tools, will be really nice to see how they interact and how they depend on each other, and how people create these tools and how they collaborate when they create these tools. So CRAN, before showing anything else, so CRAN is this comprehensive R archive network, which is like a big repository of packages. And they have this mission of trying to maintain some standards or quality checks on these packages. So you can actually access to CRAN, you can develop your own package and then you can submit it to CRAN. It's free, you just have to do some of the steps that they require for this. When you submit a package to CRAN, or when you create a package in general, so you will have a description file, and this is like the heart of the analysis. So in the description file, you are supposed to add the name of your package and then the title. And then you have to add a description of your package. So this is iGraph. The description is probably not the best one, but it's just like a sentence or a paragraph in which you specify why you create this package and what is like supposed to be doing this package. But it also include information like the dependencies. So in this case, there's only 2 dependencies, and then you can also suggest some other packages to make your package work better. And then you have, for example, the authors. And you will see that the author have these tags. So there is some authors, others are collaborators or contributors. And there is like different type of authorships here. But the most important thing here is that this is structured information that is available on CRAN. So what I did basically was use this information to conduct this review. So the method. So first thing that I did was basically take the description files for all of these packages and collect the information. So I create like a big data set with all of the description files from CRAN. And then I use this embedding methods that is basically a method that takes sentences and converts it into numbers. And when you use these big models, like in this case, I use one model for Hugging Face. These models basically assign a vector of numbers to your sentence, and then you can like store some meaning of the text. So what I was thinking is, if we can like have these embeddings of the description, so probably I can get some meaning of this package is used for doing network analysis. So what I did was basically take all of this description, transform it into embeddings, so to numbers. And then I took 15 packages, famous packages or popular packages for network. So I use like iGraph, gggraph, statnet, SNA, network packages that are like very popular. And I compute like the average embedding or the average number. And then what I did was to identify similar packages based on this embedding number. And finally, what I did was basically choose from these numbers, so the most similar, so the top 5%. And this is what I'm gonna show you, like the top percent of packages that are supposed to be packages for network analysis. And you will see, I mean, we can like do like validity checks of this classification. And then with this information, I create 2 networks from these packages that I identify as network packages. I create 2 networks. The first one is the dependencies network, which in which basically we have the node, the package name, and the edge is the dependency. And then I create the authors collaboration networks. This is a little bit tricky because then you have a bipartite or a 2-mode networks in which you have authors embedded in packages, but then you can like create like make the projection of the bipartite network and obtain the network of collaborators, right? It's like in which the edge is like the same person participate in 2 different packages. Okay, and then with this information, I create this Shiny app, which I think is the most important part of the presentation, and I will share with you the link to see the Shiny app. So to visit the Shiny app, I just have to click here. And then this is also make in art. That's why I believe this is like one of the most exciting software today. And you will see that you can find here like a bit of description of how I did this method. And then you have this package dataset. And if you click like here, see, this is a live demo, so I hope this goes well. So you have all of the packages here. You can see at the very bottom, I identify 1,089 packages. And I included the package, the title, and the description. And at the end, I included also the similarity. So this number, the bigger the number, the more similar to these 15 network packages. So you will find, for example, SNA, which is a very popular package. And then another package like this one. And then you can like see and explore all of these different packages. So this is the list of the information. Let me move this. But the most important thing or the most interesting thing is the networks. So for the networks, I use this network package that is very cool because you can interact with the network. And this is the network of dependencies. So remember here, so the node is the package, and then the link is that one package depends on the other. And you will see something that is very common in science, right? In which you have these big clusters that try to organize the field, and then you have like some other like trying to connect. And something that is very clear here is that, for example, this package is something that is very important in the network. If you click, you can see all of the reach. It's connected to the other hubs here. And if you like zoom in, you will see that this is iGraph. Of course, iGraph is done of the most popular package. Is very fundamental for many other packages. But you will see other like sections of the network, which makes also a lot of sense. So you have, for example, in this case, you have the network package, which is central to this area when you can find ergoms. And I saw tergoms here. And then, for example, statnet, I saw statnet for here too. So this is like probably the area in which many of us like use when we are modeling networks. There is other areas, for example, here. So this is ggplot, and you know that ggplot is also very important because when we create these graphics, sometimes we use ggplot as our reference. This is like a little messy here, but also very highly connected. And this is the stats, which is probably something that, of course, is very basic because many of these packages are using statistics to show. Yeah, I mean, this is the purpose of the package, to compute some statistics. So this is the networks of dependencies. You can like choose, for example, I don't know if I look for statnet or something like that. Very cool because then you can like click and then you will see the package, and then you can see like how it connects with other packages. Statnet is here, it's connected with SNA, with Tergons, with TSNA, and so on. So this is the first network. The second network is the network of collaborations, and you will see here something that is different. So now you don't have like all of these big interconnected networks. So now you have like a lot of like different people like collaborating in small groups. You have this big group. I didn't like look for who they are, but it sounds like this is a group that when they create one package, like everybody collaborates. And then you have like this cluster here, and I think this is very interesting because if you click this person, which is somebody who looks very central, right? Because it's like connecting like different hubs here. Sally Weekend, which is the creator of Tidyverse and other packages that are really popular in the art community. And something that I was like thinking is like, of course, there have to be somebody like him, right? Because it's like trying to connect like different groups of people working on the same or in different projects. And that's very different to this behavior in which people specialize in some packages and then they collaborate just in that different area. So I think this is what I wanted to show you. Just like for me, some conclusions here from this. So R is like a very big and vast ecosystem that offers several tools for neural analysis. This embedding-based similarity, I think this is something like really interesting to do. I mean, it took like doesn't take a lot of time, and the accuracy is like really good. I mean, compared to other methods that I tried, was the best. And then these dependency networks looks like the first one like a very scientific community, right? And when you have like hubs and then they are interconnected. But for the authorship, it looks like a different pattern of connections in which you have like these small groups and not too many like cross connections. So thank you. That's what I wanted to share with you today.
Thank you very much. You were right on time. Is there anyone who wants to make questions here in the room? Okay, Alejandro.
Hi, Francisco. Can you hear me from there?
Yes, I can hear you.
Just checking. Well, very interesting the visualizations and the shiny up that in which you put everything together. I was wondering whether you can expand on, or have you thought about expanding this application or this on, for example, our universe, because there are plenty of other packages that perhaps are there, and it's just a matter of the size of what cron, cron has this limitation of 5 megabytes, I think, and then some other package goes there. So I was wondering whether you have considered that, and also whether this package depends on something else. So, for example, I do know that iGraph depends on C, right, on C++. And that would be a nice information, because I personally have a small package and I always try to see how other researchers are working on their things. So this is the type of thing that I'm interested in looking at. So yeah, just see what do you think about that?
Yeah, very interesting. So for the first question, I think something that I have been exploring is these embeddings, and because you can codify meaning in the sense that the numbers that represent that sentence, they are like encoding meaning. So you can use like better search techniques. So maybe something that I could try is like, if you, for example, you put, I want to see packages for, I don't know, ecological analysis or something, and then you can like look in the different data sets because you have the embeddings and you have the meaning. And that's how many search engines are like changing right now. You know, like the ChatGPT new search engine basically use something like that, like meaning searching. So maybe that can be one direction. And the other one is like regarding the dependencies. Something that I was also thinking is like, I only scrap like the description and the author and dependencies, but you know, you could potentially get all of the, for example, all of the functions, all of the content of the package into one big file. And then you can, like, for example, identify which type of files are there, and then you can organize the information using something like that. But yeah, this is just like the first step. So thank you for the comments and for the ideas.
Francisco. Now I wanted to pass to the second presenter, as we are running a bit late, but hopefully we have more time for discussion later. Now we're going with Luka Kronegger. Luka, can you hear me?
Hi, yeah, I can hear you.
Great, because we can hear you too. All right, so Luka's presentation is titled The Role of Mentorship in Knowledge Production, and is co-authored with Alejandro. So, Luka, you can start your presentation now.
Okay, can I share the screen?
Sure. It's already loud.
It says it's disabled.
Okay.
Uh-huh. No, it works.
It should be allowed now.
Yeah, it's allowed. Let me just...
Can't see your screen now.
Can you see it?
Yes. All right.
Okay.
Ready to start.
No. Okay. We'll have to manage something like this. Okay. Well, thank you for having me on the conference. I'm Luka Kronegger. I'm from University of Ljubljana. I'm from Slovenia. I was in Chile last year, so for a few months. So that's how I got to the conference. and we worked with Alejandro for some time on a nice project connected to our quite big project on role of mentorship in knowledge production. So I'm just showing a little bit part of what we're doing. So let me start. We have a co-author, Marjan. He's my colleague from Ljubljana. So basically, the things that I've been doing for quite some years now is that I was studying with my colleagues scientific collaboration in many different ways, with many different methods, mostly scientific collaboration of researchers working in Slovenia, because this is our environment. Through all time, we were kind of working on these co-authorship networks and trying to figure out how people collaborate. And when you do just simple collaboration, and as from term of network, basically you're dealing with undirected network. And I was always envious to my colleagues that had like directed networks, and that was the thing that I wanted to try it in a way. So we ended up with this project. Anyway, when we talk about scientific collaboration, it's a bit hard thing to measure, to decide what this actually is. There is a lot of different ideas what scientific collaboration could be. It can be just people actually publishing together. This is something that we can measure. It can be just people, I don't know, having lunch together and talking about science. It can be, we are collaborating right now, being on the same conference. So it's really something that's a bit hard to say what it actually is, to define it very clearly. So let's just stick to some kind of simple definition of scientific collaboration as a system of research activities by several actors related to functional way of and coordinated to attain some kind of research goal corresponding to these actors' research goals and interests and so on. So let's do something together and let's figure out how to solve some problems. Now, when we talk about scientific collaboration, as I said, it's really broad thing, and usually when we it's the way we do things. We always have problems with measurement, and if you have some data available, you take that, and there is a lot of things in scientific collaboration that we practically cannot measure, not in an easy way, not on a large scale. For this certain current project, for instance, we're actually doing interviews and doing bibliometric analysis and doing surveys to figure out how people are collaborating, and so yeah. And usually we just stick to bibliographic analysis, and one of the things that's usually hidden in a big systems is also a certain type of scientific collaboration, and this is mentorship, and this is the thing that I'm going to talk about. From sociological point of view, mentorship is kind of the thing, very important determinant of how person is actually performing through his or her career, and the mentorship is not really straightforward thing, just like co-authorship in a way, when you don't know exactly what a certain person does that is written on the paper. In mentorship, you have like quite nicely defined who is the stakeholder in the thing. You have like mentor and mentee, or advisor, or we call advisors mentors in our system. But what is actually the content of this mentorship? It's not just writing together. There is a lot of different elements that we can have here. So basically, it can We can talk about coordination of expectations between mentors and mentees. It can be like project planning. It can be adaptation of research environment, mutual learning, who is learning from whom. And, you know, really there is some kind of knowledge transfer going on from one party to another. But, you know, we always, well, many times are trying to talk about positive aspects of these collaborations. But we cannot neglect, you know, the bad mentorships, bad relations, bad experience. Sometimes things just don't go the right way. So it's also, mentorship is also connected to conflicts, to problems and to negative ties between researchers who collaborate. So, you know, we tried to kind of pick up all of these dimensions on a different levels. As I said, we in our current project that we're working on, we did a survey and between on mentors and mentees, and you know, we looked at the personal ideas, how people look at these collaborations and so on, and so on. So we try to, you know, look at the whole picture. So, okay, the mentorship is basically a social network. You know, we talk about how people collaborate between each other, but we know that the scientific system is much more than just like, you know, collaboration of people. Basically, we have like dual system. The one part is like the social system and the social network. While you know, when doing science, we also talk about content, about ideas, about yeah, you know, actually the topics that we research. So basically, we're interested here in networks of knowledge and ideas that somehow represent cognitive layer of scientific system. And of course, science wouldn't be science if we were not be interested in you know, the new things that science works on. So in this current project that we're working on, we're looking at somehow, well, we're trying to figure it out how the ideas, how the new things pop out within the network of researchers connected to the two things. So basically, we have on one side researchers doing specific content, specific topics, and there is so this is kind of the cognitive connection of researcher towards topics, ideas. And on the other hand, we have social networks, like the network of like mentorship network, not really typical like co-authorship network that we many times analyze, but actually the mentorship network, which is not so easily accessible in you know, as in data term. So okay, what's our idea? We have a set of topics that describe dynamic relationships between authors and their research topics. So basically, we have like authors and topics that they work on. And the idea is that we use stochastic actor-oriented modeling, like the Siena, to try to model the existence of groups of researchers based on their interests. So we tried, you know, with Alejandro, we were talking about, is there a way to, I don't know, to show the existence of invisible colleges? So what is kind of bringing people together? Is there yeah, I will talk about data a little bit later, so it will pop out later. So basically, yeah, we have data on our researchers. So we have like researchers' age, gender. We have the disciplines of researchers. So it depends where they are. We have quite a lot of data on them. So our question is you know, is the mentorship somehow generator of new ideas of these people, or is just like the system in which they are working? So basically, we're using stochastic actor-oriented modeling, Tom Snyder's, and okay, it's not just Tom anymore. There's like a big group of people working on it. And the idea of our Siena is that we have some kind of model defined on continuous time Markov chain, basically where we're modeling existence of ties in time. Okay, a few words about data. And we're working on data of Slovenian researchers. In Slovenia, we have this nice system where every researcher that actually is part of the system has researcher's ID. And this system works in a way that is connected to the founding. And if you want to do the PhD, you actually need your ID as a researcher. This is one thing. And another one, we have library system, bibliographic system, where actually everything that comes into a library is tagged in a way that it belongs to a certain author. So in practice, this means that we have like complete bibliographies of all researchers in Slovenia. What I mean by complete bibliographies, I mean everything. Actually the talk that I have right now will be put into the system, so it's available. The talk that I had in Santiago a few months ago is in the system already, I think. The papers are there, the books are there, the mentorships of diplomas, like undergraduate diplomas, are there. The mentorship of master thesis, everything is in the system. So basically everything is tagged, so we can follow the researchers through their career. And this is the data that we actually are working on. And in our case, we will actually just focus on the part of the data on the social sciences. In Slovenia, the system kind of consists of 7 fields, let's say fields. So like natural sciences, technical sciences, biotechnology, medicine, social sciences, humanities, and I think we have interdisciplinarity, something. So it's a big thing. But social sciences basically consist of 13 different disciplines, like sociology, economics, and different disciplines. And the data that we are working on is based on 1,800 researchers from 13 disciplines, and we have like 3 time spans from 1990s to 2021. Our dependent network is bipartite network, like of authors times topics. So what kind of topics people are working on? The topics were gained through LDA from topic modeling. The source was basically the keywords that we already have in a database. So we didn't go and parse the actual content, but we worked on something that was like semi-prepared. And in our exploratory network, the basic idea was to have mentorship. So for these people, for all these 1,800 people, we have like who was mentoring whom in a certain time. Each person can have 2 mentors, mentor and co-mentor. But these people, these are mentor and co-mentor, are on the same level in our analysis. We have some additional variables: gender, scientific age, like at which point the person published their first publication, discipline, and this is it. So let's look at what we actually did, the model. Yeah, as I said, we have like 2 transitions, like 3 time spans. So basically, our model worked in a way that the dependent network is like author teams network. So we are modeling how the author is picking up the new topic, or dropping tie to a new topic. It's a 2-mode network, so authors to topics. So we are modeling how people are connecting to different topics through time and these are basically results. We look at, for instance, for the 4 cycles, how so how 4 cycles in 2-mode network are actually substitute for clustering. So if same people are working on the same topics, and from this perspective, we can see that we have like significant parameter, significantly estimated parameter, and this is really nice that, you know, okay, there is a structure that is built based on the topic. So here we're, you know, people of the same, dealing with the same content are working on together somehow. Then maybe I'm out of time already. So the things that are the most interesting to us was this part. So let me look at this. Are people from the same discipline working on the same topic. So we have discipline of authors, and we can see that this actually is not significant, which would mean that the collaboration between actually the doing on working on a specific content in Slovenia in social sciences is working on the same content has a stronger effect than actually being in the same discipline, which would kind of, we can explain as a kind of the interdisciplinary story within social sciences. Then we have some other things. The thing that we were kind of the most interested in was this part. So does the mentorship network affect the working on the same topic? So this is our question here, and the fact that we are modeling, testing. And we can say that that we cannot prove it. Well, this was not significant. So at the current point, we did not actually prove this, and we are still working on trying to figure it out how to actually show this thing that we believe that actually is there. Okay, so let me just conclude this. First, we tried to test for the invisible colleges. There is clear evidence of contextual communities of authors in terms of 4 cycles and same disciplines, ego and alter distance too. So there is a strong communities based on the content, which is actually stronger than the disciplinary boundaries. We can say that popular topics attract higher number of new researchers than unpopular topics. Researchers working on a wide range of topics are less likely to start to work on a new topics. We can say that researchers working on a wide range of topics are connecting to some kind of niche topics, while those working on small number of topics are covering just like the popular ones. In terms of gender and age, there is no significant effect. Or maybe younger researchers are more active in terms of opening new topics, which makes sense because they're doing their dissertations, so they're kind of like proactive in picking up new themes. And in terms of mentorship, unfortunately, we cannot prove that mentorship is actually promoting like like promoting or to pick up a new topic in Slovenia, but still in social sciences, but still we are trying to figure it out if we can find another way to show this. And this is it from me, and thank you.
Thank you very much, Luka. I don't know if there's someone in the room that has a question, comment. No, well, I do. I was wondering, like, if well, data is already telling us enough, but what could be done from like a qualitative perspective, maybe to try to explain better what happens within mentorships? If there was any questions to be asked.
Sorry, can you repeat the question?
So what qualitative questions could be asked to continue understanding better the network of mentorship relations that you have found with your topic?
Well, actually, the question. I hope I understand you right. Sorry. The thing that I have in mind right now to do next is basically the idea is that the mentorship network is a little bit too sparse to be able to, it doesn't have enough statistical power to explain the actually connections to topics. So we are kind of trying to figure out a different way to show the same thing. From the perspective of well, from theoretical point of view, we don't have a lot of different ideas what else we could actually look at. So the theory is quite straight in terms of what to expect. The first the idea is that if somebody new comes into the system of science, this person is kind of put into is socialized into the system in a way. And the question is how similar this person is. Our question is how similar this person is to his or her mentor. So that this is the direction where we're going. And basically, we already are exploring the possibilities to model, these similarities of the point of dissertation. So how much the mentor changes with the dissertation, with the mentee, and how much the mentor and mentee are similar after dissertation. Something, it's a bit complex story, but at the same time, we always have like this bunch of variables that we have measured that we will try to incorporate into the model. So we'll try to find some other methods. In terms of topic modeling, we also have some things opened. So yeah, it's a lot of things to do and a lot of things to try. And as I said, this is just the social sciences. We have like complete country data, so it can be maybe in some other disciplines things work completely different.
All right, thank you very much. That was very. Okay. Now, I want to present who's next. Roberto Velázquez, you're coming up next. He'll be presenting Does Language Allow Understanding Interdisciplinarity? Analyzing the Semantics and Sustainability Science in Latin America. There's a question in the chat, but I think we can address that. Well, they can address that in the chat, or we can discuss that later. I'm not sure. But go on.
Yeah, do that.
It's already open, yes, to meet Luka. That's the one, the presentation.pdf. The first one, yes, that one. Oh, yeah.
Roberto,
There it is.
¿podrías silenciar a Luka?
Sí.
Fácil.
Sí, porque. All right, so that there. No. That, yes. Menu, yes. You want the full screen, right?
Yes.
Ver, más abajo, ahí. No, arriba, ese. Modo pantalla completa. Control L, abajo, ese. Yeah.
Can you hear me? Yeah. Yeah, okay. Thank you very much, everyone, for being here, for taking the time to listen. So today I'll be presenting a work we've been collaborating with Alejandro, Espinosa-Rada, and Julien Vanhulst. I'm Roberto Velázquez. I'm from the Católica University of Chile, working on my PhD, but this is a different project. There's been a little change in the name of the presentation. It's Interdisciplinary as Language, a Semantic Analysis of Sustainability Science in Latin America and the Caribbean. And I would like to start by giving you a brief context of what this is about. So first, this is a project that has been sponsored by the Chilean Agency of Science and Technology, and it lies at the intersection of sociology of science and computational social sciences. And I would say that the main object that we have in mind right now is to analyze and describe the body of scientific knowledge,
The other one.
scientific knowledge production in the field of sustainability science in Latin America and the Caribbean during the past 20 years. And specifically, I would say that our approach is based on text analysis and topic modeling applied to content from the academic publications and paper abstracts. That's the main landscape of the research. I would like to give you some theoretical framework of how we have been approaching our questions and the entire research. And I think the first point we would like to highlight is the fact that interdisciplinary research has been increasingly recognized for its potential to enhance communication, right, and collaboration across academic fields. But this is also a question about how methodologically this specific issue has been approached. And we have noticed that we have two very well-defined bodies of literature. One is about approaching interdiscipline in science production from the perspective of bibliometric analysis. So you have paper citation patterns or research impact patterns. And on the other hand, you have the complex network approach, right? So you have collaboration or authorship networks, co-citation networks, etc. However, relatively few studies have addressed this issue from a perspective that places the focus on scientific ideas expressed mainly through language, right? So language itself. And from that point, I would like to say that from a social-linguistic perspective, scientific ideas are seen as content that is transmitted across semantic context through words, right? So words are the main manifestation of ideas in the first place. And so words embedded in scientific fields arise from concepts shared across various disciplines, forming a dictionary, if you will, or a repertoire of meaning that serves as a common language. That would be our take on, which means basically that our observations are words. Right? That's the first or the most important source of variation, words. And in this approach, the social semantic context shape words, right, and vice versa through language usage, creating a productive space for us to analyze the impact of interdisciplinary communities. That's how we will to call it for now, at least, of scientific ideas. So having that in mind, we wanted to explore this from the perspective of applications in Latin America. But so how did we get the information to do that? And it was it was an intense process of collecting information from two main sources, I would say. One is OpenAlex, right? We needed the abstract because that's the main source of our observations, the works, right? So we accessed OpenAlex and we made a query to extract all the papers using sustained as or keyword, right? But we also wanted to have all the information that comes from each paper in terms of variables, such as, let's say, citation numbers or references or the year of publication or the name of the authors. So what we did was combining both of these sources to create the main, what we call at least the corpus of abstract from 2000 to 2001, right? So we ended up having this large data set that you can see, well, it's very clear that in time, at least if you separate the period, 3-year period into a 5-year gap, right? You can see definitely how there's an exponential growth in that, right? So in the first 5 years, we have 1,000 or so around that number, then 3,000 publications, and 9,000, and finally 22,000 publications or so. So in terms of design, we wanted to address this issue, because you can definitely tell that we don't have the same amount of data for each period, right? We definitely have different numbers in terms of the first 5 years as compared to the last one, right? We have 22,000. So what we did was separate the corpus we had into 4 different periods. And one of the main aspects of our design was to mainly use this non-structured data to create a documentary matrix, right? Because this is the way that you process all that has to do with semantic analysis or at least topic model. So what we did was first, of course, all the process of data wrangling, which included, cleaning the data set and extracting or removing stop words, stemming the words, creating the dictionary. Finally, or the main point maybe, I don't know if I can do a zoom in here, but you can tell, right, we have non-structured data in the sense that we have a string of characters, right? And this is not the way that you process it. You have to transform into a documentary matrix, which means you have to have 1 token per row. And so we spend a lot of time, just even doing the transformation to, a 1 word per row data set. And so we mainly wanted to explore the themes or topics that you can find within this set of knowledge production. And I just wanted to give you if you already know it, my apologies, but just a brief definition of what a structural topic model is. And well, a structural topic model basically evaluates the probability of a document belonging to a specific topic using conditions, or probabilities that belong to document level covariance, which means that there are aspects that are embedded in the papers, that may affect the topics that the literature, is producing. And so what we did was include all of these, different aspects that go from the level of interdisciplinary integration that you have in each of the topics, to the paper size, gender, or the predominant gender in the paper, the number of citations, right, the number of references, and the year. So I would like to now talk specifically about this variable we have that is interdisciplinarity. That is something we wanted to build using social network measurement. This is probably the most network aspect of this research, particularly because we wanted to use something that is called a two-mode relational similarity. Classify papers using the fields, scientific fields, where they were published according to the data we extracted. So we ended up having 291 disciplines, and we wanted to cluster them in order to have different groups of fields, and then we had the opportunity to classify them based on which fields were connected. The two-mode relational similarity comes from it's based mainly on Breiger's 1974 seminal paper, the value of goods and persons, and then also on Kovacs 2010 improvements, and actually last year, Marjan published the implementation of this. And so basically what it does is that we have a two-mode network. It's a network of paper and fields, right? And what this specific measurement does is to use the one-mode projection of these networks. So we have a one-mode projection of papers and a one-mode projection of fields. And so the two-mode relational similarity allows us basically to calculate, using cosine similarity, different groups where these entities could be grouped. So you have just for the sake of description, these are how we estimated each of these. But the main point here is to show you the results of these two-mode relational similarity measurement. So we ended up finding, three very distinct groups of fields. And when we review the list of disciplines or fields that we found, we could definitely tell there were different levels of interdisciplinarity. There was for each group of 5 years, So in the first one, we have high levels of interdisciplinarity. You can tell, like, if you see, there's a cluster of publications that were connected, and they came from human geography, political economy, international law, hydrology, urban planning, right? You can tell actually it's heritage. And you can, if you compare this with the other groups, let's say with cluster 2, which is just an example, right? You can tell that it's less, if you will, interdisciplinary. We have molecular biology in this case, in this example, biotechnology, chemical biology, biostatistics, biometrics. And this is, since this is, a reciprocal entity, it's a dual network, you could, at the same time, extract the papers that were, or that belong to each of the clusters. So this is how we classify the fields. It was more, if you will, this is, sorry, before that, this is the result of the two-mode relational similarity measurement. You have at least 3 distinctive groups of fields that we code, classify to create the variable interdisciplinary. Instead of just assuming that something was interdisciplinary, we decided to empirically estimate it. And this is, the table just summarizes the results that we got. Just, a general, I'm not going to read all of them, it's just to give you a general idea of how the process ended up. And instead of conclusion, maybe I will, if you have ideas or comments on this, I just wanted to say that our expected result, or maybe what we wanted to achieve, is that if you use a structural topic model, you can actually estimate the statistical effect of different, interdisciplinary levels for each of the topics. So if in this case, I'm not gonna delve into that, but we estimated 13 topics. We have the variable interdisciplinary, and then we can estimate actually the level of the statistical effect of the interdisciplinary levels on each of the topics. So this is actually where we are right now. We are working on the interpretation of the results. I would like to know if there's any comment from you, or maybe insight on how we've been developing this methodology, and know from the work community how do you think this could be received, especially because the main take on this paper is it's on structural topic models, but we decided to include this very interesting social information. So thank you very much.
Thank you very much, Roberto. Does anyone have questions or comments?
Yeah, I don't know what to make your question, but I also use that kind of models, and I was curious about how you make the prevalence specification. I saw like a regression within the
It's not a regression, it's just it could be equipped to a logistic
yeah, so the result of the logistic goes inside the prevalence model, or
no, this is just a way to put it, to define that. The generating algorithm, what it does is that classifies, considering or conditioning for specific, variable, and the probability of a document within a topic. That's one of the probabilities that a structural topic estimates. But at the same time, it estimates the probability of a word in a topic.
perfect. And regarding the two, what's the name?
Two-mode relation.
Two-mode relation. Similarity, yeah. The MP matrix is a matrix, right?
Yeah.
Is it the projection of the theta matrix? Okay.
Exactly. So it's a two-mode network.
Yeah, so this is not the documentary matrix, is the actual output of this STM.
No, it's not. Yeah. So the STM is the model that predicts, the documents within a topic and the words within a topic.
Yeah.
But we wanted to condition those probabilities having an empirical measurement of interdiscipline. How papers belong to different interdisciplinary communities. So that's why we use, the two-mode relational similarity to estimate how fields were clustered in different communities based on the similarity, the positions within the one-mode projections of this two-mode network. And the two-mode network of papers and fields.
Yeah.
This is just to create a variable, actually, but it was, it was a very interesting process to include this social network measurement to just, have a, instead of rather assuming that something is interdisciplinary, we decided to estimate it using a two-mode. Yeah. Thank you. Yes.
So just on that there, the gender, how on earth did you manage to?
Well, that's very interesting that we didn't have to take that decision because it was already in the data set.
Oh, really?
There's apparently this algorithm that predicts yeah, because it's something that it was created by SciSciNet. So what they do is apparently they train an algorithm that predicts the probability of a paper, of a paper's gender, if you will, but it's based on the proportion of, if there's more women than men in a paper, it's predominantly female, if you will,
But it doesn't wait that it's a first author or something like this.
No. It's just a proportion of the gender of the people who publish. Yeah.
Using AI.
Yeah. And we didn't have to.
Very good.
Yeah.
Alright.
Thank you.
Can I add?
Yeah.
Maybe you can also use the R package generalize, which is the one actually that we use it because also it's not only about the name, but also use information about the country. So, which is cool, actually, I think, because obviously, maybe Francisca is another name.
Yes, yeah, definitely.
It's for male, maybe in another country.
Yeah. But that's something interesting because we have an idea of how this prediction works. And I think definitely it categorizes the name of a person. But as you were saying, this is based on context, you cannot assume definitely that a name indicates a gender.
We use it with Lorena and Matias Montero.
Okay. I
In
will
that
ask you
paper,
that.
we use it, and it worked really well.
Perfect. Thank you very much.
Perfect.
Thank you.
We're passing to your presentation?
Yeah.
Yeah. Yes, I'm seeing that we have like a 30-minute coffee break later, so it's like if we pass for some minutes, it's fine. I'm sorry for making everyone run, but thank you very much. I'm gonna ask you like 20 more questions later with a beer, something. All right.
Go to close this.
Yes. Stop taking the time. Not yet. Your presentation is already open, I think. It's there.
Yeah, so thank you all for staying till the end. Some of you didn't have a choice. But how do I put this on? So my name is Ignacio Toledo. I work with Paulina from the School of Design at the Universidad de Desarrollo. Our presentation is called, is named Exploring the Evolution of Academic Collaboration Networks in Design Research. Okay, so why did start doing this study? Well, the School of Design celebrates its 25th birthday this year, and we are thinking on how will be the next 25 years on design research, and that implies looking the past, the present, and reflecting on what future. And our own curiosity, we talk about this with Paulina many times, but it was the CISONet conference that made us to take the decision to go for it. And we started this like a couple of months. So these are all preliminary results. I do the disclaimer beforehand. So I want to start with a little bit of context. So what is design? Design is a very polysemic term. It's never easy to define what designers do. I was like preparing a joke, like how many designers are in the audience, and we have one. So yeah, it seems like a nonsensical phrase, but each word has a correct use of the word design. Is a noun as a field, is an action, is to design something, is the previous design before you put it into the production, and once you produce something, it still is a design. It's what a beautiful design has that car. So it's very difficult to define it, and that it has some implications into how do you find the literature. So if you in a second we will take that into more deep. So looking into the history, design was originated with the Industrial Revolution, and it has its foundations on the Bauhaus school in Germany in the 1990s. And well, after the war, some of the ex-Bauhaus alumni establishing the School of Ulm, and they put forward this design as a creative discipline. So along with the formalization of the university model of education and passing from the movement of arts and crafts to this practice discipline as a professional activity, when design goes to the established in universities, gets this like academic dimension, and that is design research. Designers start researching, but not in a disciplinary way. Designer has to migrate to other schools to have their PhDs in the sociology school, in the psychology, and then they bring back that knowledge and start looking at the discipline from the outside. So what how the user experience are configured, but not from a disciplinary perspective. And it's not until the early 90s or the end of the 80s that the first PhD programs on design start to appear. And with that, it becomes like more or less a discipline. So this is a controversial issue in what we in sociology of science, for example, what it is a discipline with. Does it have a paradigm? It does have a established set of research methods, how do they make their hypotheses? Do they have a theory? All those questions were part of the discourse in the beginning, and we focus on the Design Research Society as a source for data, since we tried with OpenAlex like searching for design research, and all what we find was 200,000 results with policy design research, structural design research. No, but not a design research as from the disciplinary view. So Design Research Society has these conferences, and we decide to explore the evolution of academic collaboration. Again, academic collaboration as co-authorship. It has its limitations, and we have heard this in the past presentations. We start from here, from collaborations as co-authorships in the fields of design research, using these conferences as source of data to start exploring these questions: that is there evidence of emerging research community in design? And if there is, do they have a research program in the terms of, I don't know, Lagatosh, science of science, but no, it's not science of science, but philosophy of science. Yeah, do designers have their own research program? So as data, we collected conference papers from the DRS digital library that covers from 2002 and to 2024. There are biennial conferences. Every 2 years, they get together and present them. And the information that we have is the title of the papers, the authors, the institution, abstracts, keywords, and the object identifier. This is a glimpse of what is the digital library of the DRS. So here we have a specific screenshot of what is the available information for each paper. Is what I said, like the title, the names, the institutions, abstract, etc. So for each conferences, the page has the whole list of all the publications that were submitted. That is repeated for each of the 12 conferences in the period. So how we analyze this with some basic descriptive indicators for the structure of the network. We analyze each conference, and the cumulative network, since with 1 year we will see now that there is not much opportunity to capture a real network, since it's very difficult that these researchers put forward more than a work, or submit more than one work to the conference of. And we also perform a structural topic model for the abstracts to see what are the top topics that we can find in the discourse of this community, and how these topics have evolved in time, and the correlation between these topics. So naturally, analyzing single conferences, we find a limited number of works presented, and the networks are very sparse. This is like, I will not stop.
You don't find it.
Thanks. So we have we can see that the increases in the time, but in the number of these clicks that represent collaboration.
What happened there?
Yeah, those are like papers with 10 authors. It's not like a real network, but some complexity starts to emerge from this. And I repeated the same exercise, but adding up all the conferences. So this is like the accumulative links. Of course, it doesn't have this like a moving window. It's not a established period that we analyze through time, but the whole aggregate through each year. So we start looking since the network starts growing very quickly. I only capturing the giant component of the network that year. So the component with the max size is still very, very small, and start like building up. And starts merging with some of the previous clicks, and already by the 2020 it starts to emerging something more complex, more like with some sense of a structure of a broader network. So this is the whole picture of the whole data by the 2024. These are 22 years of the accumulated collaborations. And comparing the aggregated network with the single conference for each period, we see that the amount of accumulated papers is what is the total number of papers we analyze is around 4,000 and 2,000 and fraction unique authors that with the time accumulating all the data, the density drops and the diameter of the network increases. That is like not surprising, of course. The same with the average path length, as the network, the main component starts to building up. There are more nodes that I can reach that are in far that are farther, and the same with the clustering coefficient that drops down. Comparison with when we have like this soup of pure clicks. This is the size of the largest component that in 2020 that really like explodes, makes this jump. So and passing to the structural topic model, we use the year of as a covariate to estimating the topics. We estimated the model for 20 topics. Each one has the titles are in Spanish, sorry for that. But the main topic of the community is methods and process of the design, scientific methodology, that's represent like works with research, knowledge, science, field, methodology, discipline, practice, scientist, and other more disciplinary concerns like co-design, participatory methodologies, communities, social co-design, co-creation, and other topics like the design for future or design for sustainability, for sustainable futures, ethical design, the feministic approach, climate justice, and all these like sustainability-oriented topics. And other more like education of design, and many of the lower the topics on are like oriented like for industrial design or graphic design for like disciplinary concerns, and this evolves in time. We can see that like the 5 topics that are in the top started with less than less than 10%, and by the 2024 they reach more than the 50% of the whole discourse of this community. And here we have like the future, the sustainable future design, service, public policy, sector government labs, experience services design, user-centered design, and emotions. And that's another like emerging topic. This is like health and well-being, design for health and well-being. And this is like this participatory methodologies, co-creation, co-design. Those are for the last 20 years, about 10 years, the emergent topics that are dominating the discourse. And well, so that's what we have to now. It's a working process. Of course, we have data to keep pushing this. We have affiliations. We can do community detection. We can put the text on the analysis of the network. We can put the network into the analysis of the text. So there are these are like our the next steps we envision. Of course, improve the visualization. I mean, I know my networks are awful, but that's all. So.
Thank you very much. Actually, I believe that's like one of the most aesthetically pleasing examples of mapping the field I've seen, so it's not so bad. I don't know if anyone has questions?
Of course, I have one.
Yes, oh, right, that is fine.
Yeah, we were talking before, yeah, you told me, I'm working on the design school, oh, me too, yeah. But when in the opposite side, because you're an engineer going to design, I'm a designer going to engineering school. So, very mixed, yeah, that's great.
There's this.
So, yeah, I have a question because it's difficult to see in design schools very specific approaches to what is design. So sometimes, well, design is a very interdisciplinary field because I have, for example, mates in the school that comes from sociology, anthropology, and are engineers, you know. So it's interesting to see this kind of perspective to see what's happening in a kind of meta level. We have the field and we stay in another level. And in this sense, I have I don't know if you can go to the topic ranking, please. Yeah,
Yes.
this one. Yeah, this is a very interesting thing because design is a word, it's a field that below this field we have many different expressions of design, from textile, from industrial design, from the visual design, from I don't know, animation, interaction, many things. So and I would think that maybe something that you can consider, because the first one it was surprising for me that or maybe not surprising because method and process of design. It's a specific topic.
Yeah.
But I think that if you can make a double click inside this specific topic, I mean in the double click in the sense of you have a more specific view, because the name itself is method and process of designs, maybe can involve the other ones, because for example there's a lot of method and process of design related with interaction design or related with a more specific subfields, you know. So
Yeah.
I think it's a meta field that can involve different fields. So can be in specific view about this topic, we can make it explode and see what other fields are hidden.
Yeah, so that's funny with topics that they're not containing each other, that it's like they interact or they are correlated.
Okay.
So this topic can appear in a publication with the disciplinary
More specific
approach, more specific approach. It's like maybe design processes and methods for textile and fashion design, and as well for industrial design, and that's a good question. So topic 18 should be correlated with more than a field, and here it is. is clustered with sketch representation, image, characterized text, visual, this is graphic design. And topic 2 is design tool behavior artifact, weight idea, application method. That's like the conceptualization of design. And we can explore this if we are interested.
Yeah, we can. Thank you.
I'm sure you have a lot of time to discuss about this, but we are running out of time. We actually ran out of time already. Thank you very much for your attention and your resistance. Now you can have your break.